Capacitors. Capacitor is a device used for storing charges. They are widely used in radio and television receivers and in transmitter circuits. The earliest capacitor was invented almost accidentally by Van Musschenbroek of Leyden in about 1746, hence known as Leyden jar. The modern capacitors consist of two conductors of any shape separated by insulators like glass, air, vacuum, plastic, and so on. The simplest capacitor is made by sandwiching a piece of paper in between two pieces of aluminium foil as shown here. This may not be a perfectly good capacitor in terms of its storage capacity, but it can store charges. When the terminals of a charged capacitor are connected by a piece of wire, sparks are produced showing that the capacitor stores charges. Capacitors can hold enough charge to light a flashlight bulb for a minute or more. Displayed here are the various types of capacitors. Representation of capacitors in circuit diagrams. In circuit diagrams, a capacitor is represented by either of these symbols. In either symbol, the vertical lines, straight or curved, represent the conductors and the horizontal lines represent wires connected to either conductor. Charging and discharging of a capacitor. A capacitor is charged by connecting the conductors to the terminals of a battery. Displayed here is a capacitor connected to a battery and an ammeter. To charge the capacitor, click on the key. Observe that the ammeter reading is decreasing to 0. This indicates that the charges are flowing from the battery to the capacitor. Now click on the key to discharge the capacitor. Observe that the pointer of the ammeter is moving to the left of the 0 mark, indicating a reversal in the direction of flow of charges. After some time, the needle comes back to the 0 mark, showing that the capacitor is completely discharged. To measure the rate of flow of charges, follow the instructions. The rate of flow of charges is measured by connecting the positive terminal of the battery to the negative terminal of the ammeter and negative terminal to the positive terminal of the ammeter. What do you observe? We observe that the ammeter reading is decreasing to 0. This indicates that the capacitor is getting discharged. The ammeter gives the measure of charges in the reverse direction. Capacitance. The magnitude of charge on each conductor is proportional to the potential difference between the conductors. Q is directly proportional to V. Q is equal to CV. The ratio of charge to the potential difference is a constant and is called the capacitance C of the capacitor. The SI unit of capacitance is called farad in honor of the 19th century English physicist Michael Faraday. Difference between a capacitor and a battery. A battery has two terminals. Inside the battery, chemical reactions produce electrons on one terminal and absorb electrons at the other terminal. A capacitor is a much simpler device. It cannot produce new electrons. It only stores them. Did you know that the storm clouds in the sky are huge capacitors?